Hey guys, today's video is about model evaluation. Today we are going to start section 2, model validation, and we'll introduce the concepts of training set, validation set, and testing set. What we do is to split the original dataset into 3 smaller subsets: training, validation, and testing. But why would we even bother to do so? First, it's unfair to use the same dataset to train the model and evaluate the model's performance. If we do so, the model's performance will be overestimated. In fact, this argument can be illustrated by a simple example. That is, the past exam questions should not be in the real exam, right? Students are trained using the past exam questions, and the exam is used to evaluate the student's performance. If the past exam questions appear in a real exam, students can just memorize the answers from the past exam and get a high score. In this way, students' performance will be overestimated and unreliable, and the same logic can be applied to the data mining model. Second, if we use the same dataset to train and evaluate the model, it will be hard to tell whether the model performs outstandingly or it overfits the data. Suppose we have a model with high accuracy, 95% for example. Should we just accept the model and present it? Not necessary. If the accuracy is measured on the training set, then this high accuracy could be overfitting. In other words, the model managed to fit the training data pretty well, but it might fail to generalize the overall pattern and perform really bad on unseen data. This is what we call overfitting. However, if we use different datasets to train and evaluate the model, we can kind of make sure the model doesn't just work fine for the training data and avoid the problem of overfitting. That's the two main reasons why we must split the data for different purposes. But how do we split the data exactly? There are 3 common splits you can consider. Basically, the percentage of data for training, validation, and testing can be 60, 20, 20, or 70, 15, 15, or 80, 10, 10. There is no specific criteria of how to split the data, but the guideline is to preserve enough data for training, because that's how the model learns, and the model can typically learn better with more data. Now we can discuss what training set, validation set, and testing set mean exactly. Training set is the data used to construct a model. By constructing a model, we mean adjusting the internal parameters. For example, for a linear regression model, the model is essentially the formula y equals to a times x plus b. The parameters for this model are the coefficients a and b, and the parameters will change to fit the training set better. Then, validation set is used to tune the hyperparameters of the model by validating the model's performance during the training phase. The hyperparameters is also called external parameters, and the hyper in hyperparameters implies these parameters are top level. These parameters don't change when a training set works. They have to be determined beforehand, and that's why they are top level. I know we haven't talked about neural network, but we have to decide the number of hidden layers before the training data works, and that number is fixed. So the number of hidden layers is one of the hyperparameters in neural network. Last, testing set is used to measure the final performance of the model after completing the training phase. Since testing set is never used in the training phase, we believe the evaluation on the testing set can represent how well the model generalized to the unseen data. Alright, let's review how these datasets are used when building a model. We start with the training set, and we train a model based on the training set. Next, we use the validation set to evaluate the model we just created. But this is not the final evaluation. It's still in the training phase, so we can still adjust the hyperparameters. So, After the hyperparameters are modified, a new model will be trained based on the training set, and during the time, the internal parameters will be adjusted. This whole process is called training phase, and it will be repeated several times and stored in the memory space of computing software. Then, we pick the model that performs the best on the validation set. It's really important that the model's performance on validation sets is not the final evaluation. It's just how we select the model from a bunch of models. Finally, we evaluate the model's final performance on the testing set. This final performance will be used to compare with other models. For example, during this algorithm, we might find the best decision tree, but in fact, neural network could be the better option. To make a justifiable decision, we compare the model's performance on the testing set, because testing set is never used in the training phase. Consequently, this step is what we call evaluation phase. The model's performance on testing sets honestly shows how well the model generalized to the unseen data. So we can use these evaluation results to compare with other models and select the better one. In case you are still confused about validation sets and testing sets, I want to do a quick comparison. Both validation sets and testing sets are used to evaluate the model's performance. The difference is validation set is used in training phase, and it can tune the model's hyperparameters. So during the time, the model is still adjustable. However, for testing set, the model is the final model, which is the model that works best on the validation set. But because validation set is involved in the training phase, we shouldn't use it to evaluate the model's performance. Otherwise, the model's performance will be overestimated. Therefore, we evaluate the model's performance using a dataset that is never used before, which is testing set. The key is, validation set is used to tune the hyperparameters and select the best model possible, and the testing set is used to evaluate the model's final performance, and it can never be used in the training phase. Alright, that's the basic idea of training set, validation set, and testing set. Thank you for watching my video and see you soon.